All right, in today's notes, we're going to look at parabolas. Start off Unit 6. We're going to be graphing parabolas. And so in these notes, we're going to talk about what a parabola is and the different features and parts of it. So first of all, really simply, a parabola is the graph of a quadratic equation. And remember, a quadratic equation is any equation in this form, y equals ax squared plus bx plus c. And so very quickly, the quadratic equation is one where x squared is the highest exponent, so degree 2. So quadratic equation in this form. And so a parabola is the graph of that, and it looks like this kind of U-shape feature here, this sort of soft V that kind of goes up and out forever. And there are a few different features that we should look at. So first of all is the axis of symmetry. And so this is just the line of symmetry through the parabola, and it goes through the vertex point, which we'll talk about here in a second. But essentially it's this line here. And the equation of this line is x equals negative b over 2a, which is given right here. And so if you take the b and a values from the form, from the equation, that's c, b, and a, and you put them in negative b over 2a, you'll get the axis of symmetry. Now the vertex point is the point that goes through. It's either at the top or the bottom of the parabola. In this case, it's the bottom, because this parabola opens upward. And in this case, it is the point 1, negative 1. But obviously that will change depending on the specific graph you're working on. But the x value of the vertex point is always the axis of symmetry, which in this case is the line x equals 1. Okay, now the solutions of a parabola, the solutions of a quadratic equation are going to be the x-intercepts. And so in this example, our solutions are the x values 0 and 2. These are also known as roots and zeros because they're where the equation equals 0, the x-intercepts. And so typically we have 2 solutions, but sometimes you'll just have 1, or sometimes you won't have any, depending on where the parabola is on your coordinate plane and where it opens. The opening direction is really simple. You can just look at it. This one opens up because the kind of open part of the V or U is up above the vertex. If you imagine it flipped, that would open down. So when A is positive, and that's the first value of the equation, when A is positive, the graph is going to open up. And when A is negative, it will open down. So minimums and maximums. We're talking about the y value of the vertex. So think of y as your vertical direction, your vertical axis. So the y value of the vertex is a maximum value for this graph when the graph opens down, so when the vertex is the highest point, and it is a minimum when the graph opens up. Now this current example, this would be a minimum because the vertex is at the bottom of the graph. So our current example here is a minimum, and that would be y equals negative 1. So you imagine this here is like the lowest this graph can be. And that's why it's a minimum. The graph does not go below this line. Y equals negative 1 is the minimum value for this graph. And then increasing and decreasing. So this is where if you look at the shape of the graph, and you can just go from left to right, and you can see that from left to right, the graph is going down. It's decreasing on this side, and then it's going back up on this side. And that can be tricky because sometimes we draw these with arrows, right, here and here. So you might think it's increasing on both sides. But you want to look at it from left to right. And from left to right, this graph decreases until we hit the vertex, and then it increases. So the function increases when the graph goes up from left to right, and it decreases when the graph goes down from left to right. and that changes at the vertex. So this will depend on whether it's opening up or down, whether which side of the graph is increasing or decreasing. In this example, like we showed, it's decreasing on the left-hand side and it's increasing on the right. So to make that kind of simple, to kind of write that in mathematical terms, it's decreasing for values of x that are less than 1, which is the AOS, right? That's the x value here is 1, and that's where the vertex is. So from x values less than 1, it is decreasing, and for x values greater than 1, it is increasing. All right, so those are the basic parts of a parabola and the kind of information we can get from that. So we know if it opens up, A is positive, opens down, A is negative. We have the vertex point, the axis of symmetry. Those are very important features when we get to graphing in the next set of notes. The solutions of the quadratic equation are the x-intercepts, and we can say and know where this graph is increasing or decreasing, which can also tell us which direction it's opening and things like that. So here are the parts of a parabola.